You must have recently heard that a part of the sun has broken off. Astronomers saw a huge plasma filament erupt from the sun, surprisingly pulling itself apart. And after getting detached, it furiously rotated till it reached the star's north pole, creating a terrifying vortex, just like a gigantic tornado. But how is it possible for a solar chunk to break apart? What's the physics behind this intriguing event? Finally, and most importantly, does it mean that a solar tsunami is on its way to hit our planet? These are some important questions, and to answer them, let's look at what happens on the sun step by step. Every 11 years, the sun's activity undergoes dramatic changes due to magnetic field reversal. The magnetic poles flip their position, meaning the north becomes south and the south becomes north. This period of 11 years is known as a solar cycle. In one complete cycle, the sun transforms into a roaring beast, from being relatively quiet and peaceful at times. At its peak activity, the sun is stormy and is accompanied by an increase in the number of sunspots and frequency of solar flares and prominences. These three terms are essential to understand what really happened to the sun. Sunspots are regions with strong magnetic fields and relatively low temperatures. They can have a temperature of about 3,800 Kelvin. That's about 2,000 Kelvin cooler than the surrounding photospheric temperature. Because of that, sunspots appear darker than the brighter photospheric background. On the other hand, a solar flare represents an intense eruption of electromagnetic radiation in the sun's atmosphere. Both these features are known to blast high-energy plasma towards Earth. However, besides enhanced sunspot and solar flares, another important feature that appears during peak activity is solar prominence. Suppose plasma flows along a loop of the sun's magnetic field from sunspot to sunspot. In that case, it forms a glowing arch that reaches thousands of kilometers into the sun's atmosphere, creating a solar prominence. Simply put, a solar prominence is a large, bright plasma feature extending outward from the sun's surface. As the internal dynamo of the sun generates a magnetic field, the plasma in prominences twists along the magnetic field lines. Over time, the twisted magnetic field structure becomes unstable, forming an erupting prominence. As a result, we see outward bursts of plasma. In some cases, the prominences can also loop hundreds of thousands of miles into space, covering distances much greater than the Earth's diameter. Furthermore, a prominence forms over timescales of about a day, and stable ones can persist in the solar corona for several months. And possibly, something similar to an erupting prominence has happened recently. Solar prominences are pretty common, once every solar cycle. They form at about 55-degree latitude and later march up to the solar poles. There they disappear to come back again after 3 or 4 years in the same region. The most surprising thing in the latest solar prominence observation is how the material broke off. The ejected material circled the pole at 60 degrees latitude for about 8 hours at 96 kilometers per second, and the reason behind this phenomenon is still unknown. Solar physicist Scott McIntosh, who has been observing the sun for decades to understand the cycles, said that he had never seen a vortex like the one that occurred recently. Currently, the sun is in its 25th recorded solar cycle and possibly at the edge of a solar maximum. Astronomers expect a polarity flip in July 2025. However, these predictions are based on the behavior of previous solar cycles. One cannot ignore the fact that not all solar cycles are alike. Some cycles are stronger and others are weak, but the current cycle has been quite different. Since its beginning in December of 2019, the sun's activity has skyrocketed. It has flared up almost every day of the year so far, something astronomers didn't expect so early in the cycle. It even spat out several X and M-class solar flares in January. Flares of these two classes are the most violent ones the sun can produce. The dynamic event highlighting a part of the sun getting torn apart was captured by NASA's Solar Dynamics Observatory on February 2nd. However, researchers still have limited observation data because the event occurred at the solar pole. The poles are pretty challenging to observe, as most satellites launched from Earth travel in the ecliptic plane. At this position, it's difficult to see the sun's poles. Although it's possible to leave this plane, it's quite hard and time-consuming. So we need to wait a bit more to know the exact mechanism behind such a rare phenomenon. The good news is that this event won't impact our planet much. Since this eruption occurred at the sun's north pole, it's not directly pointed at Earth. This means that it won't harm our satellites or disrupt the GPS and radio communications, which some solar eruptions are known to have done in the past. For example, in February 2021, a solar storm destroyed 40 newly launched Starlink satellites. So although the prominence itself won't impact our planet, it indicates that solar disturbances will continue to increase for a while. A thorough analysis of such features is required to understand what exactly is happening at the poles of the sun. Recently, the Parker Solar Probe touched the sun. If you're wondering why didn't the spacecraft melt, you can watch this short video that explains every aspect of the technological achievement. Also, make sure to subscribe to our channel so that you don't miss any astronomical updates.